So what are we going to do today is, first we will be having a doubt solving session where you can ask questions for what we have covered till now. Okay, so first we'll have this, like we'll have first half an hour, 45 minutes given to this. Okay, second we will go with visualization and its interpretation. Okay, we'll go with that. We'll understand visualization. So specifically we'll be understanding libraries like Matplotlib, Seaborn. Okay, we'll be understanding them. Okay, then third we will do univariate and normally bivariate analysis. Okay, so it should be a part of your visualization. Then once we complete this, at the end we will have hypothesis testing. Okay, anything more you want to add, guys? No, I think the answer is no. So let's start. So one thing before that, you should download this video and tell it to, because you know the size, there's a size restriction. So I'll be deleting this video say by tomorrow evening. So you should download it and confirm me on the group that you have downloaded the video. Okay, so that I can delete it and upload videos from today.
Okay, sir.
Okay, now let's start with the doubt solving session. Okay, so I hope you were practicing whatever things we are doing. Okay, now today it's your chance to tell me what you have learned, what problem, what challenges you are facing, if anything you want to repeat. Okay, so we'll be spending some time on that. Let's start with that. Okay, so who's gonna start first? I'll just open a Jupyter notebook for that. GA10 EDA. Okay. Yes, guys, let's start with the doubt solving session.
सर कैन यू रिपीट द रोलिंग फंक्शन?
Okay.
कल पांडास में किया था.
Okay, rolling function. You want to understand rolling function? Fine.
Yes, sir.
Okay, I'll just do this. New Python notebook. So it will be doubt solving and your visualization. So you want to understand rolling function, right? So import pandas as PD. First we'll pull some data set. Okay, so we'll use the same stock market data set. I have something stored over here in my downloads, I think. NSCI. Okay, this is the same NSCI data set. I'll just put it over here for our reference.
Hello.
Yes.
Sir, I have doubt regarding yesterday's thing.
So right now we are solving rolling function doubt. Okay, then you can
Okay, yeah.
then we will solve your doubt. Okay, so I'll just read this file.
Yeah, yeah.
Okay, this is my file. Okay, something around that. DF30 types. Okay, but there are some other variables also. I need to delete those variables. Still showing some variable. Now it's okay. Okay, so what is rolling function? I'll show you. Right. So df dot date will first convert them to underscore date time. Date time df date. Okay, df dot d types. Okay. Okay. Now rolling function. What does rolling function does? Rolling function basically what does it do is it rolls a particular window in either direction. Like it will roll it in downward direction or roll it in upward direction. Let's say we are trying to make a rolling rolling average of a window 3. Okay, so what it will do, it will take these three values from the close, calculate its average. Okay, calculates its average and place it in front of this observation. Okay, this will be the first step. Say if I do rolling 3 period. Okay, now in the second time what it will do, it will take these three variables, these three values, calculates its average. Okay, this will be average 1. Okay, then there will be average 2. Okay, it will put it in front of this observation. Okay, then in third iteration what it will do, it will calculate the average of this. Okay, calculate its mean and put it over here. So you can see this window is rolling, right? It is rolling from this over here, right? So that is called as rolling average or rolling window. Okay, so I'll show you how it works. Okay, so df close dot rolling. Okay, and rolling, if you give 3, it will take 3 period. Okay, like these 3 observations calculates its whatever thing you want to calculate. I want to calculate its mean, I can calculate its mean. I can, if I want to calculate max, I'll calculate its max. So I'll store it in rolling. Okay, I'll store it over here. And df dot head, it will be helpful for us. Okay, now let's see what it has done. It has rolled 3 period. First of all, it's a 3 period. So 1, 2, 3 observations. What function I'm asking it to do? Do a max. So what is the max of these 3 period? If I look at it, it's 1, 2, 2, 8, 2. And it is putting over here. Then what it is doing, it is going to the next 3 period, like skipping this row. So now this is the next 3 period. Okay. No, what does it is doing? It is
बट
yeah,
बट सर यहाँ पे नैन वैल्यूज आ रहे हैं तो फिर हमें उसका मतलब कैसे मतलब मिसिंग वैल्यूज हो गए ना फिर भी वो तो फिर
राइट।
हम उसको
तो हम
कैसे
लोग क्या
हैंडल
करते हैं,
करेंगे?
ये जो लाइंस रहती है ना, फिर सो ये लाइंस को हम लोग डिलीट कर देते हैं। जब आप रोलिंग एवरेज कैलकुलेट, रोलिंग कोई चीज में फीचर्स जनरेट करते हो ना, तो आपके पास दो ऑप्शन, बेसिकली टाइम सीरीज में जनरेट होता है रोलिंग फीचर्स। ओके,
ओके
आपके पास क्या होता है, फिर आप इन इन ऑब्जर्वेशन या तो डिलीट कर सकते हो या इनको यही वैल्यू से रिप्लेस कर सकते हो। ओके,
ओके।
सो दैट्स ऑप्शन।
बट सर यहाँ पे ये रोलिंग फंक्शन हम बट कहाँ पे यूज होगा?
कहाँ पे यूज होंगे?
यूज कहाँ पे होगा? मतलब उसका यूज क्या है रोलिंग फंक्शंस का?
रोलिंग फंक्शंस,
मतलब वो टाइम
यस बोलो ना।
मतलब उसको यूज कहाँ पे करेंगे मतलब टाइम पीरियड कैलकुलेट एग्जांपल बता सकते हो क्या आप हम
राइट,
कहाँ पे यूज कर सकते हैं?
सो रोलिंग फंक्शंस रोलिंग फंक्शन बेसिकली टाइम सीरीज जो प्रॉब्लम्स रहते हैं ना, टाइम सीरीज के बेस्ड प्रॉब्लम्स, उसमें यूज होता है। प्रॉब्लम सच एज, ओके, स्टॉक प्राइस प्रेडिक्शन फॉर एग्जांपल, ठीक है। then you have uh, then you have some sort of sales volume prediction, okay, or you want to calculate, say, quarter to quarter rolling descriptive stats, okay, or you want to do a weather forecasting problem. So इन सब जगह पे तुम लोग रोलिंग फंक्शंस, और भी कई है, और भी टाइम सीरीज प्रॉब्लम लाइक सेंसर एनालिसिस, सेंसर डेटा एनालिसिस, okay. So there are almost, in financial domain, majority of data is time series data. Okay, so you can use them in time series based problems, rolling functions, to create, you know, to generate lag features. Okay, so these are basically called as lagging features. Okay, you can create lag features or you can create these rolling features, lag features or rolling features. So now your question will be why it is used. Okay, what is the thing that makes it so helpful in
यस सर।
time
हाँ।
series predictions? में क्या होता है, हमारे पास टाइम डेटा होता है, राइट? वी हैव अ डेटा से फ्रॉम हियर टू हियर, ओके, फ्रॉम 01, 02, 03, 06, 07, okay, and I want to predict what will be the probable close of 08, okay, समझा क्या?
फ्यूचर प्रेडिक्शन के लिए
फ्यूचर प्रेडिक्शन,
फ्यूचर प्रेडिक्शन
हाँ, फ्यूचर प्रेडिक्शन के लिए।
ओके
जैसे मेरे पास ये
ओके
1 जनवरी से लेकर 7 जनवरी तक का डेटा है, एंड नाउ आई वांट टू क्रिएट डेटा फॉर 8th ऑफ जनवरी मुझे प्रिडिक्शन करना है। ना मेरे पास एक ही डेटा है, लाइक क्लोज का डेटा है, ओके। सो हमने देखा था वी हैव टू वेज, सुपरवाइज्ड लर्निंग एंड अनसुपरवाइज्ड लर्निंग, राइट?
यस यस
सो सुपरवाइज्ड लर्निंग में हमें कैसा लगता है, वी नीड टू हैव अ फीचर सेट, independent variables, a feature set, and then we have to have a dependent variable, right, which we are going to predict,
यस सर।
right? So हम लोग क्या करते हैं, हम लोग ये रोलिंग फीचर्स क्रिएट करते हैं। नाउ our assumption is basically कि अगर हम लोग यहाँ मीन लेते हैं फॉर एग्जांपल, ओके, एंड इसको एक पीरियड से शिफ्ट करते हैं, ओके, नाउ यू कैन सी दैट इन तीनों का मीन जो है, इन तीनों का मीन यहाँ पे आ गया। ये इतना समझो आपको।
यस हाँ।
नाउ व्हाट इट इज, this holds some information about past, right? Some information, like 3 period means hold some information about past,
यस
okay. In similar way of 3 period mean, I can create say 7 period mean. Then I can, so this will be a short term information, okay.
यस
Then this will be, say, a medium term or a medium term information, Okay, say 7 days ले लिया, then we have some say 20 period, 20 days का ये, so this will be a long term information.
Yes, sir.
समझा? So now we are
Yes.
creating some sort of features out of that. Okay, and this holds some info because
Yes.
हमको time series prediction करना है and we need to have some sorts of informations, like तो हम लोग univariate time series
Yes.
supervised learning problem में convert कर सकते हैं. Okay,
Okay.
and so this is one way to solve this time series forecasting problem. Okay, the other
Okay.
the other way to do that is there are methods like arima, arima. Okay, so these are classical statistical method which you can use to solve this time series problem. And you
Okay.
can also use LSTMs, RNNs, or GRUs to solve, like neural networks. Basically, these are neural networks.
Okay.
Okay, so this basically takes a two form, like it will take univariate time series. So in this case, in univariate time series, you don't require to create these features. You can give this adjusted close and try to forecast time series. Okay, but
Okay.
in LSTM also you can give you can give only adjusted close and try to predict it, or you can give some features also like generated on this. And this supervised learning, you can use this generated features. Got your point?
Okay. Yes, sir.
Okay, does it clears your doubt?
Yes, sir.
Okay, next question please.
Yes, sir.
Yeah,
Sir, yesterday I have done HTML parsing on for ITC data, like you have done for Wipro, na?
right.
So the thing was I tried to slice data,
Mm-hmm.
like just one column could be sliced, but simultaneously two columns or three columns couldn't be sliced. So is there any way to slice
No,
it?
no, I didn't got your point. Like you are not able to slice multiple columns.
Yeah,
You are pulling
I
ITC
have
data.
checked for ITC data. Yeah,
Okay, let's try.
like for just a minute. For the CSV file, we use calls equal to column names, no?
Mm-hmm.
So in this, for read underscore HTML data, there is no function like that. I have checked in help too,
Mm-hmm.
but for parsing multiple data, what we have to do?
Means you have to pull multiple columns from your ITC output, right? That's what.
Right, right.
Okay, let's try your ITC data.
It is limited.
This one.
Yeah.
Okay, let's go to historical data. Now this has pulled me the ITC table. Okay, I think it's not the daily data. Let's see. So this is calling the bid ask price dollar table.
I have done, sir, for the summary table. No? I have pulled some summary data.
Mhm. We have pulled this data. Mm-hmm.
This date, open, high, low, close, adjacent, close, and volume.
You have pulled this data.
Just a minute. No, sir. I think that was, I think, historical data only.
Okay.
Not getting it exactly.
Mm-hmm.
But in my table, there is a date, open, high, low, close, adjacent, close, and volume.
So you have pulled historical data only.
Yeah, this one.
So I have pulled this data. Okay, now this is a list. I want to extract the first table, so I'll do this.
Right.
Okay. Now you are saying you are not able to pull multiple columns out of it, right?
Yeah.
So what you use, lock, iLock, or what?
Sir, I use directly the method for the method used CSV. That is a PD dot read underscore HTML bracket में that link.
Mm-hmm.
And I tried for use calls, but use calls were not there.
Mm-hmm. Yeah,
And
because you will not get that function over there. So it's not there, then you have to
yeah.
use some
So
other way.
in help also I have seen there, but there wasn't any
So you should
multiple.
have
I
used
didn't find any multiple columns.
iLock or lock na, to slice data.
Okay.
Or other way it could be, what you can do, you can parse a list over here like this. Date,
Huh.
just like open. Okay. So now this can be another option. Okay.
Okay.
So if you want all
Yeah.
rows and some specific columns, you can do like this.
Huh. And sir, to replace the NaN function in it, I tried that too. But for there is a just a minute. In high there is three NaN functions for that column.
Mm-hmm.
I tried to do that sum into 100 divided by length of df, but in high there is like its final value is not 00. It's 0.006584.
I
So
can see
for NaN, in high there are three NaN.
is null.
df dot df dot url dot is null dot sum. I use that function.
You cannot see any null values over here in my data actually.
Uh, I got three NaN sir for
Okay.
there. I will try it again. Okay.
Mm-hmm. Any other
Done. Thank you, sir.
welcome. Any other questions?
Other was the
Can you
same
explain,
question.
sir,
Rutuja has.
JSON?
Yes. One by one. Like
Can you explain, sir,
Yeah.
JSON?
JSON. Okay. So basically JSON is what? JSON is a file which looks something like this. I have this JSON file, and it looks like this. You have levels in this, okay? Level 1, level 2, level 3, and you have to extract data. So then what you have to do is once you read it, you have to go step by step. Like you have quiz, then you in that quiz you will have sports, you have Q1 quiz options. So yesterday we saw reading JSON using pandas. Okay, there is a JSON file also. There's a JSON package also which can help you. We'll see that. Reading JSON file in Python. Okay, so let's file. Sorry. What was the file name? Example 2 dot str object has sorry. Let's see what how it wants us to read. It wants us to read a file object. Okay, so we have to open it and then we have to read it. Okay, so file equal to open JSON and we have to read the file. Okay, so this is the file that we have got using JSON, right? So same file, I'll save it in JSON. Okay, now if I let's say quiz, okay, you first understand the structure. You have JSON, you have quiz as the top level. Okay, in that quiz you have two sub levels. One is, so understand the dictionary. Okay, you have quiz, then within quiz you have two sub things. One is sports, one is maths. Okay, this is maths, this is sports. Within sports and maths you have two things. One is Q1, which is a question, and within Q1 there's a question, there is an options, right? Similarly in maths, there in Q1 and Q2 there are questions and there probable option and answer. Similarly in Q2, questions, option and answers. So you can refer it like this. Like when I do quiz, I'll get what's inside the quiz. Like quiz ke andar kya hai, I'll get that. And then if I have to extract sports, so I can extract sports. So this is the sports ka data. Okay, now let's say if I can make this to this to just go date time. Okay, data frame. Now you can see this, I'm getting Q1 question and answers in 3 different rows. You can convert rows to columns and all those stuff, so you can do it with it. Okay, if I have gone more further, okay, can you see this? Now we have converted a JSON file to a pretty neat data frame. Like I have question, I have option, I have answer.
Yes, sir.
Similarly we can do it for maths. It's maths. What is this? You have Q1, Q2, you have question, you have option, and your answer. If I want to extract what's the option, what is the questions, I can do this. Okay, sorry, it's an index. It's an index. So I can do lock question and everything. So I can get all the questions. Samjha?
Yes, sir.
Okay. Yes, what was the other question? Can you repeat how to download JSON file? Akansha. Akansha, I just downloaded some random JSON file. It's not, I just downloaded a sample JSON file. So it will be generated by some process, probably a server call or something like that. It will generate from them. Okay, what other questions are there, guys? What are the doubts? We have time to solve doubts. One, there are how many people? 15 people. Come on, guys, tell some doubts. if you have practiced. Yes, Ashwini.
सर हम लोग ये जेसन का यूज कहाँ पर कर सकते हैं?
जेसॉन का ना यूज बहुत आता है. जेसॉन बेसिकली जब आप डिप्लॉयमेंट करते हो ना मॉडल्स का, ओके, तो यू नॉर्मली वर्क विथ फ्लास्क और Django kind of a thing. ठीक है, इससे जब आप HTML में डेटा पुश करते हो ना, that goes in JSON format, okay, and जब HTML से या वेब पे से डेटा वापस आता है ना हमारे पास, like this रिक्वेस्ट करके जब कोई रिक्वेस्ट फायर होता है, that data also comes in JSON format, okay. से आपका आपने कोई एल्गोरिथम डिप्लॉय किया है, ओके, it has some features that user needs to input, so data रिटर्न आएगा ना आपके पास, it will come in JSON format. This is one example, like in deployment. अब जहाँ भी आपका वेब डेटा से कोई डेटा आ रहा है, तो that will come in JSON format.
ओके, तो जाते समय वो HTML फॉर्मेट में ही जाता है?
नहीं जाता है.
HTML और फिर
नहीं, जब यहाँ से कोई डेटा मेरे सर्वर से HTML में जाता है स्टैंडर्डली, तो दे यूज JSON फॉर्मेट, ओके. और जब HTML से कोई डेटा हमारे पास आता है रिटर्न, ओके, so it also comes in JSON format.
ओके सर.
Okay, preferably, right, there could be other format, but preferably JSON आता है. That's what people prefer to do.
So the video which you uploaded on Google Drive, sir, it is not converted. I think we need to convert it.
Okay, because that conversion was taking 2 days or 3 days at my system. Is that so?
It's showing me like 4 hours 3 minutes
Okay, in your system?
for one video.
Okay, it will take too long.
Yeah.
In my system, because my system runs different things also, na? It was taking a long time. You can put it on convert. Like,
So what I'll do is, so I'll convert it and put it on like private placed on YouTube. I mean, everyone can access later.
okay, yeah,
If it works for everyone.
okay. If it's decided, so keep it on private video. Don't put it on public sites.
Private. I'll keep it private
Okay,
playlist.
okay, no problem. Fine. Okay, what other questions, guys, you are having? Let me go on asking you, unmute yourself and tell me that you have no questions or you have some questions. Okay, Abhishek Shukla.
Hello.
Yes, Aditya.
सर कैन यू टेल अबाउट मिसिंग वैल्यूज, मतलब मिसिंग वैल्यूज जहाँ पे होते हैं एग्जैक्टली हम लोग वहाँ पे क्या करते हैं, लाइक yesterday can you give some examples?
Okay, we need to get some examples for missing values. ठीक है, मिसिंग वैल्यूज किधर थे हमारे पास? कोई न्यूमेरिकल के अंदर मिसिंग वैल्यूज चाहिए मुझे, तो देन आई कैन शो यू. Let's search for some data set. Missing value data set. डेटा क्लीनिंग चैलेंज. तुम केगल के डेटा उठाते कोई तो. क्या है डेटा? डेटा रखा है क्या? बट इधर I'll just find if there is a data. I don't find the data over here. Let's find something. We'll search some data set. Missing value. Let's say this इसमें बस कुछ missing values है क्या? Okay. I don't see इसमें कोई missing values रहेगा. Let's keep this real estate data set downloaded. It will be useful for us today. Okay. Any more missing values? Let's see. और कहाँ हो सकता है? लोन डिफॉल्ट केस स्टडी में देखता हूँ, इसमें रहेगा कुछ ना कुछ मिसिंग वैल्यूज. So back, and one more back. Okay, well, this is your case study today. Okay, I'll just read this file and see if there are some missing values. df equal to import. Sorry. pd.read underscore csv. And what's that? loan.csv. df.head. Okay, there would be missing values in this. Let's see how we'll handle the missing values. df.isNull dot sum, length of df. Okay, now I'll convert this into a data frame. pd.data frame. Okay, I have this data frame, and we'll have columns equal to missing value. Okay, so this is my df underscore missing. This is the loan ka data set. Now there is one function that I need to tell you. Okay, now you see that I have this id, member id, as my index. Can you see that? Yes. So I don't want this as an index. I want that 0 1 2 3 4 as my index. So there is a command called reset underscore. Just say we have set underscore index now. We have reset underscore index in place equal to true, and drop equal to false. You have to do this, huh? Drop equal to false. So now df underscore missing is this. Okay, it's a data frame. Now what I'll do is I'll filter all those missing values. So I'm showing you how we are handling the missing values, okay, in an overall fashion. Greater than, say, 0.5. Okay, so these are the columns that have, so these many columns have 1 1 1, all the values missing. Okay, and okay, and these had some 97 64. So what I'll do, I'll drop all these columns. So let's take the index and make a list of it. So this is a list of all columns that have more than 50% missing values. Okay, got till here? Did you got, guys? Did you get
Yes, sir. Yes.
Okay, I'll store it in L1. Now, what is L1? L1 contains all the list of all the elements, all the columns that have more than 50% missing values. Now what I'll do is I'll drop all this, because these anyway I'll not be able to, you know, what we say, manage more than 50% of the missing value. That is creating some vaguely dummy data. Okay, so it's not preferable. So what I'll do, I'll just drop this access equal to 1 in place equal to true. Okay, now I'll again run this. Now it will have all those values which are less than 50%. Okay, so employee title is there, employment length is there, description is there, 0.32, then revol util is there, last payment date, and charge off within 12 months. Okay, these columns are there which have some missing values. Let's check the data type. From where okay, df dot, this is a check df dot d types, df dot d types. Okay, so if I see over here, like employment title is of use employment length. Okay, employment length is what? Employment length कहाँ क्या? It's an object. Let's see what's there in unique. pd dot unique df and so this is the thing, like 10 plus years. Now this is an object. Okay, now what you can do is you can find the because this is an category, you can find, you know, the mode of it. Mean, median, mode, right? Mode is used when you have categorical value. So you can see that the highest number is for 10 plus years of experience in this loan data. Okay, so you can replace this column with this employee length dot fill na 0 in place equal to true. Okay, because what does mode says? Mode says which of these categories is repeated many a times. Okay, like maximum number of times. Okay, if you want this, we can also check like the frequency distribution. Import from collection, import counter, right? This function we saw in the class collections. Now I can do a counter df emp length. Okay, now you can see that 10 plus years of experience is almost double than the next best category. Can you see this? Okay, it is okay. Now one thing you can see that you have this is 1000 observations. Okay, which is, say, what is the length of df? 397. And out of that, this 1000 is how many percentage? 1075. It's 0.02 or 2%. Okay, 2% of your data is missing in this column, so you can replace with this, like this is way high. Or what you can do, the other thing is you can, you know, create a category, like you can remove years, you can have 10 1 2 3 4 like in numbers, and then take an average and then replace it with that number of years. Okay, there are different ways, it's up to you how you want to handle it. Got it?
Yes, sir.
Okay, any other questions, problems, challenges you are facing? Ruchita, Priyanka, Ashwini, Tejas, Rahul, Aditya, Akansha, Kaustubh, and who all are there? Poonam, Prathamesh, Sanat.
Can you explain, sir, regular expression?
Regular expressions. For that, I'll quickly explain you regular expression, but for that you will require a full 4 hours lecture. That will still not be,
Sure.
yeah,
Just
yeah.
overview.
I'll show you overview of regular expressions. Okay, regex builder online. So what does regex do is regex is basically used to find patterns in the data. Okay, let's say this is my paragraph with 100% accuracy. Okay, some random statement, and you have some mail, gmail.com, something like this. Okay, now how does this work is you try to find some pattern. Okay, let's say I want to find all the t's, so I'll just press t's. You can see that these t's are uh, highlighted. Okay, now I want to find, so this cap gives at the starting of the sentence. Okay, I want to find if there is a apple at my starting of my sentence. So it gives there is no apple. Now I'll write another sentence. Okay, apple is good fruit. Now you can see there is an apple in the starting, so it is finding it. Okay, similarly I can find, let's say I need to have an email address at the end of the state, at the end of this. So let me try gmail.com at the end. So this is finding this. Let's say arshian@gmail.com is my email. So now you can see this is a first statement where you have @gmail at the end. Okay, so this dollar sign indicates end of the statement. So if it finds this pattern at the end of the statement, it will highlight that line. You can extract that line. Over here it's at the in between, so I cannot find it. Okay, now there are some special keywords. Okay, like /w. /w means this pattern, like anything A to Z, capital A to Z is written on underscore. I can find any A to Z, any number of characters, okay, with @, then I'll have any number of characters, okay, then .com. Okay, so what this pattern will do, this pattern will basically find any email addresses in my paragraph. So if I have some paragraph, some data like this, like ematicus _02 @yahoo.com, so it will find that also, like any type of email address in the data. So this is the power of regular expressions. So you can extract patterns from your textual data, or you can extract patterns in a particular column. You can use it for filtering. Okay, say suppose you want to find a date 09/20 is created on 09/12/2021. So you need to find this kind of a pattern in data. So understood how Gmail, how you can find what you can say email. So in this way, how you can do is /d, it will find digits. Okay, /d will find digits 0 to 9. You can say question mark. So that question matches the previous token between 0 and 1 times. Okay, so or you can say I want this 2 times. Okay, or match digit 2, sorry, I can do this 2 times. Okay, then I need a slash. It's an escape character, so I need a double slash. Okay, so you can see that this is not getting highlighted, so then you have to find some way to work with this. Okay, so I'll do this. Let's finding all digits. Now I can say any character. I'll say digit. I need to have any character, like I can give like this. Okay, or not equal to, something like this. You have to give. I have to check over here what you can give. Any non white space character. So I'll give /c, and then I'll again give d star. I'll again give a non space character, and again I give a /d star. Okay, and this should be say at the end of the statement. That is the dollar sign. So you can see that this is identifying this. That's not a perfect thing. You have to tune it and make it perfect. Okay. This is some way I have created to identify this email address. Sorry, this date. Understood?
Yes, sir.
You have to practice. If you want to learn regex, you have to practice a lot.
Okay.
Okay. You have to find what patterns. You have to remember them. There is n number of patterns. Like you can see this. There are lots of patterns over there. Any more questions? So we'll start. Else we'll start with visualization. Any more question, guys? Girls, guys, girls. Any more? No questions. Ruchita says no questions. No questions. Okay, fine. Then we'll start with visualization. Okay, we have downloaded this data set archive. What's there in archive? Let's try to unzip it. If I can get some data over here. Okay, extract here. Okay, this is the data. Age, DS, RM. So the reason why I take data from from scratch in front of you or from Kaggle, because it helps me to solve it and you know how to solve it. Okay, let's say which data set we want. We can get the cards ka data set. It can be easy to solve. Let me get the cards wala data set for you. This is situative. Okay, car price. We will try to visualize this car price. Have we covered car price data? I don't think so. We have covered, right? Okay. We'll try to cover car price data. Okay. Let's see. Well, first, okay. No, sir. Okay, that's cool. I might have covered another batch. Let's see. So this is the data set. df equal to pd dot read underscore csv car price dot csv. I'll start with visualization and its interpretation. Okay. So we will first look at different types of visualization. Okay. So what type of visualization we have? We have bar plot. Okay, we have line plot. We have scatter plot. We have histograms. Okay. Then we have we have line, we have scatter, we have histogram. Then I was just remember to stick off my tongue. A box plot, pie chart. Okay, pie chart. Okay, so these plots, we'll first see how we can make these plots, then we will do it on car price assignment. Okay, so for doing it, you want to import matplotlib.pyplot as plt, import cbon as sns. So cbon sns is a library which which can beautify your matplotlib graphs. Matplotlib graphs are very, they are good in visualization, but they're bit dull into that. And cbon provides a very good like ggplot kind of a visualization over there. Okay, so first we'll try to plot a what we can say, a line plot. So we had this nsci, right? We'll call this data df date equal to pd.to underscore date time df date. Okay, so we will go with this df dot head. Okay, now what I want to do is I want to plot a line graph. First I'll check d types, it's float. Okay, then it's okay. So first you have to start plt.fig. Okay, this is the starting of your plot, plt.fig. Okay, what important things you can have is fig, sorry, figure. I'll need to put a help over here, help plt.fig. Okay, or sorry, figure, it should be figure, plt.figure. It is a fig size, face color, edge color, frame on, figure class. Okay, clear false. We are only interested with this fig size. Okay, so figure, then we have fig size. We can have a size like 20 by 5. This is a figure size. Okay, and you can make a clear equal to false over here, so it will clear any previously created figures. Okay, with this, and you can give dpis and all those stuff, constraint layout. Okay, if you got it, we clear that. Okay, now next is what sort of a graph you want. Let's say I want a line plot, so plt.plot will plot me a line graph. So we are now doing it with matplotlib. Okay, plt.plot. Now I need to give, so let's see what plt.plot have. Plot. Okay, we need to give x, we need to give y. Okay, so I'll give x. X will be right now my df.index, so df.date. Okay, and y will be df.close price, and plt.show will basically show your figure. Okay, there is some error, unexpected. Okay, there is a scale x, scale y. So okay, scale x and scale y. Okay, there is some issue. If I pass like this, what happens? Okay, now my line plot is there. Okay, you can see that at the downwards there are my dates, so date is properly arranged. Okay, and I can see the line graph. Okay, now how I can format this graph. I need to format this graph. Okay, now okay, well, I need to format this graph. So what are the things available to format this graph? Let's go down. X and y, we have given x and y. Okay, data, then okay, plot. If you go bit niche, you will have this marker style, marker width. Okay, so first I'll change the color equal to whatever you want to give. Red, I'll give red color. This is my red color, right? Now I want to increase the line width, so It's what, width equal to 2. There is no thing called as width, line width. Okay, now my line has become a bit thicker, right? Okay, now I find that this graph is, I want to make this graph more bigger, okay, or more smaller. So I can do like this. Okay, so you can have a more smaller graph. Okay, now I need to have some markers. So markers equal to, I'll say I want a plus as my marker. Okay, markers, there is no argument called markers. Okay, there has to be some other argument. It is marker, I think. Okay, marker, not S. So I'll do marker. Okay, so these are all my markers, like dot, star. And I can make marker in different colors, like marker color is there, or what? Marker color, let's see if there is something like this. No, there is no argument like marker colors. So what we have, marker face color, or you can use this MFC. I can use this marker face color MFC. Okay, so this इसका face color ये हो blue हो गया रहेगा. We are not able to look it, but yeah, it would have been like, if you make dots, now you can see this. And marker edge color, I mean, let's say it's also blue. Yeah, okay, now I can see that blue color over here. I'll make this as plus. Okay, you can see this marker colors. Now I have plotted this. Now I want to plot a, now I want to give a title to this graph. Okay, so like this, TITL title, Nifty coronavirus or COVID recovery analysis, something like this. So I have now that. Okay, over here, like Nifty this is what I am doing. Okay, now I can give X label. X label will be, say, time period, and PLT dot Y label, say, close price. Okay, so I have that things now on my graph. Okay, so you saw how I started with a very rough graph and how it's changed to a beautiful kind of a stuff. Okay, now let's see how this graph will look in C1. So we need to change SNS, and there is line plot. Okay, then it's still now looking the same, but if I do SNS dot set, now you can see that the background has changed. The what you can say, the text over here is now little bit beautified and good than what we had over here. Okay, got it? How you can create a, one thing we left over here. I want to give a title to this line. Okay, so label equal to close price, that's what we have, and then we can have plt.legend lock equal to best, like lock is location. Okay, so you'll get this is close price series. Now similarly you can add multiple things over here. Okay, like I have close price, I can say I can have a high also, which would be in say blue. Okay, blue with say red markers. Okay, red markers, and I'll have a hi. What happened is invalid syntax where I have made a mistake. Have I made a mistake somewhere? Oh, यहाँ पे. Okay. Now there are two plots, right? You can see the blue line. You can see the red line also, right? So understood how you create a structure of a single plot? Akansha says yes. And what others are? Have you? Priyanka says yes. Okay. Okay. Yes.
Yes, sir.
Okay. So this is how we create a line plot. Okay. Now let's see. We'll keep the structure same. So once you are aware of the structure, you need to keep it same. If you want to create a single plot, we will see how we create subplots also. If you want to create a single plot, you need to keep it same. Now let's say we need to create a bar plot. Bar plot. I'll just show this. Here I'll have volume. Okay. Now what's it is saying? Volume की spelling गलत है. VOLUME. Volume. Okay. sms.bar plot. There should be. There is no argument marker. It will not have marker in that. I'll just remove from everything from here. There will be no line width and all those things. I'll remove things from here. I can keep label. It is still working. It will take time to. Oh, it's taking too much of time. It is taking time, guys. Till the time you have any questions, you can ask me. जब तक ये graph plot हो रहा है इसका. हाँ, ठीक है, हो गया. So you can see that this is the graph, and because of date, it's not so good. So I need to increase the size a bit. It's taking time. You should wait for that. Okay, I understand. So date is, that we are not visible. The date is not visible to us. So we can probably try to do something else with that because it's a very long data. Okay, so you see how you can plot a bar plot over here. Now what else plot type are remaining to understand? Okay, we need to have a scatter plot. Okay, let's try to have a scatter plot. Let's see scatter plot documentation. SNS, the documentation for SNS and matplotlib remains same. Now try to use this only because it will give you a good what you say, visualization. Okay, now let's try the okay, let's try scatter plot. Okay, now I'll just say sns dot scatter. Okay, I need x, so I will be plotting high. So now I want to do an analysis. Okay, so this is df my dot head. Okay, what I'll do is I'll create a returns column. Okay, returns, basically दो दिन का return क्या है with close to close. So how I'll do it, close divided by df dot close dot shift 1. Okay, and then I'll have daily returns, right? So it's -1 into 100. So df dot head, so this is my return, 0.8% return minus 0.55% return. Okay, now I'll try to plot a scatter plot. Scatter plot, let's say we'll plot in some other way. Okay, df, so high low के range के अंदर we'll see low, and then first let's see what is this. So this is high low. Okay, this will plot high and low together. Okay, or let's say we will let's say close and returns. Okay, so how the returns is divided with close. Okay, so close price, this does not make sense to me. Like, what is this? I don't know what is this. I'm not understanding it. Like, close is 14,000 मेरा return इधर है, close was 8,000 मेरा return इधर है. So this is of no use to me. So I'll try to refine my analysis. Okay, so what I'll do is I'll do df minus close and df open close का जो range है, ठीक है, this is open minus daily movement कितना है market के अंदर. Okay, we'll take this and we'll see. Now it makes sense. Okay, if the movement is in the negative direction, my returns is negative. If the movement is in positive direction, my returns is positive. Makes some sense, right? Let's say we do a shift of this, like previous day का open close का range से हमारा current day का returns कितना ये है. Okay, now you can see that all the returns are distributed around 0. This is what we saw yesterday, right, in distribution. We saw this in yesterday in distribution. Yes or no, guys? Yes. Okay. So mean is, so you can see that you consider this as a normal distribution. So everything is scattered around mean. There are few outliers around. Okay. So this is what is normal Gaussian distribution. So this is how scatter plot is plotted, and you can find out this kind of inference out of it. Like if my previous day daily range is minus in minus side, my current day returns will be negative. If it's in positive side, my current days returns will be positive, right? Now we have this. What else graph type is remaining? Histogram. Histogram we saw yesterday. SNS.histogram and DF returns. Okay, this is a histogram of distribution. This is equal to this. Okay, this is returns and this is count. So you can see a very smooth normal distribution over here. There are few things like KDE equal to true, which will put a normal, which will try to put a normal distribution, Gaussian distribution on top of it. Okay, then after this, what we have? Histogram we covered. We have box plot. Okay, now we'll see the box plot of returns.
So,
Yes.
so can you tell me how you got that return value? Close divided by close. I'm just thinking about that.
Which value? This value? Returns value.
Close. Returns value.
So this is close. So how my data is? Okay, this is my data, right? Till here we have the data. Now what is returns? What is returns on
Yes, sir.
anything? Okay, what is a percentage change? Instead of returns, call it as a percentage change. What is a percentage change? Current minus previous upon previous, right?
Yes.
This is percentage change. Okay, so how can I get previous price? I can get shift 1. This will give me this price.
Mm-hmm.
So
Yes, sir.
this price divided by this price minus 1 will give me what percentage change, right?
Okay, that means
And
the
yeah,
first one divided by second.
yeah, this divided by this, like shift 1 matlab this will come over here, like rolling हम करते तो shift भी यहाँ पे इसका
हाँ.
फंक्शन यहाँ ले आएगा.
Okay.
Okay,
हाँ, हाँ. हाँ, sir. हाँ.
समझा? So this is how I calculated this.
हाँ, sir. हाँ.
Okay,
Okay.
now this is your
Yes,
box plot. This is a box plot. Box plot, what does box plot shows? Shows your median value, your and your outlier. So you have some outliers here, here. This is your IQ interquartile range. Okay, and how your, is there an outlier or not, how your data is distributed. So your data is pretty close to mean, right? You can see that 75, 25 to 75, like 50% of data falls over here, right? Within 0 and 1%, something around that. And almost what? 0 to some percent of your data, IQ or range data is in this. Like 2.5% on negative side, 2.5% on positive side. Got this box plot? Any question in box plot? Okay, no. Then we'll see the last pie chart. I have never drawn pie chart. I have to even look for documentation. Pie chart. Is there any pie chart? Create pie chart. Okay. Matplotlib has an option of pie chart. For that, we need some sort of a group by. Okay, so let's say we have date, right? df.head. We have this date, we have this returns. What I'll do is I'll just take this date and returns. Okay, and then I resample it on a monthly basis. What is happening? date time got a range index. Okay, so I need to set underscore index date dot resample. Okay, and what I have to do is I have to take a mean return. So I'll take monthly mean returns. Okay, so I have this monthly mean returns. Understood how I did this? What I did over here? Did you got what I did in this line?
Sir, can you repeat this?
Okay, so what I wanted to do is df dot head. So for drawing a pie chart like contribution, the pie chart is what contribution, right? So to create a pie chart, I need some sort of a smaller data set of this, like a summary of this. Okay. So what I did is I want to get a what is average monthly return of Nifty 50, right? What is the average monthly return? Average monthly daily returns, okay, whatever it is. So I need two columns. First of all, date and returns, right? So I have these two columns, right? Now I need to resample it on monthly basis. Now when I'm doing this, it is saying me only valid with date time index, time delta or period index, but got a range index. Okay, this means that what if I look over here, my index is what 0 1 2 3 4. Okay, and what it is saying, it is wanting date as an index. Okay, date time as an index. If I this is my date time, it want this as an index. So how I will set this as index? Set underscore index date. Now this will set my date time as an index, right?
Okay.
Now I have to resample them at say monthly level. Okay, and so when I do this, I'll get this. It's a object. Now I have to define some function. So I need to say I need to have a mean of the returns. So when I do the mean, I get for
Okay.
every month I'll get some mean, right? For this 12 months.
Okay.
Okay. Now I have this. Now I need to plot it. Okay. Now let's say how to plot this. There is something called plot.py. Let's try to use this first. If this works, dot plot.py. Pi requires either y column or subplot to be true. Okay, so it's saying that pi require a subplot, or pi requires either a y or subplot to be true. Okay, so I'll do a reset underscore index. Okay, and then let's say if I get it drop equal to false, it's still not giving, so I need to do it some other way. Okay, so monthly, I'll save it in some data frame. Okay, now reset underscore index in place equal to true. Okay, df underscore monthly. Okay, now this is this. Now I need to plot the pie chart. So I'll go here, I'll go here, I'll go here. This is group by. Okay, this now here. X data. Okay, I need to put some X data, data.keys. Labels is data.keys. Let's try to plot it. Even I have not plotted many a times this. plt.py. Let's if we pass dhy date df9 dhy returns. It is giving me some weird thing. It is giving me a pi, but it's giving me some weird thing. Okay, so I'll just remove this. I'll just wedge this edge. Label equal to df underscore dhy date. That is labels No, it's not working in that way. Pretty easy, bit more fancy. Okay, let's try to copy this only. Let's try to work on this folder only. It requires some sort of other language. Now my data is data labels, returns. Okay, and my label is df underscore and dhy date. There is some name error, monthly. There is again some value error. X must be non-negative. Okay, fine. Because pie chart is basically what it does is it gives me the contribution, right? So what we can do is this. Let's, for the sake of our doing the things, explode must be of length x. Now we need to, so I'll just remove this explode command from here for time being. Okay, now you got this. This is how we plotted the pie chart. Very crude, very complex, but you can plot it. Okay, this is, we don't go with title on this thing, but yeah, we were able to plot it. Why this is giving me this? Let's see. Almost everything is coming in 199, 199 range, right? Because it should be positive, and it should. Okay, let's see. Let's only plot the magnitude. So apply np dot have. So let's try to plot only magnitude. Import numpy as np and np dot abs absolute. Let's say -1, 1. Okay, so I'll apply this instead of that. Dot apply np dot absolute. Let's see if this works. Now you can see this is more good than what we have, right? It is now showing the percentage. Got it? There are some 24 percentage, like here it's 26, 27%. Okay, that's why there are some months having large, like this is March, which was where there was corona fall. This is having a large contribution in percentage change. Got this, guys? Everyone, any questions how you can plot things? Any questions, guys? No. Prathamesh says no. Clear. Is your matplotlib and SNS clear? Okay, now what we will do is we will do a EDA exercise. Okay, we will do a EDA, complete EDA exercise. We will do an EDA exercise. Okay, so for that we will read underscore CSV. We will read this car price assignment. This is we will read this file. Okay, and this is basically a car and its price. So it's a data set where you have different data about cars, model, and its price, and we need to do some sort of analysis on this, like what insights we can get about car price. So the objective that we are trying to follow is, so our objective is to drive to find what things drives the price of cars. Okay, so this is our objective. We need to find what things drives the price of the car. Okay, so with the help of visualization, we are not doing any machine learning, we are not doing any linear regression to find out which parameter is important, but yeah, we need to find out. Okay, so first we have checked the head. Next, what we'll do is we will try to see the D types. This is object, object, object. There are lots of object. Okay, so what we'll do is, for the sake of me doing the analysis, we will concentrate on car name. How does car name affect the price? We'll see how does uh, city mileage and highway mileage affect the car of the price, affect the price of the car, and how does horsepower affect the car of the price. And then today is Friday, right? So you will be having an assignment, and you can use that to solve this, or you can practice on this either way. Okay, so we'll do this now. We'll start first on the symboling. We can use symboling also to test it. So we'll start with car name. Now, understanding effect of car name or brand on car price, right? This is what we want to do. Now, first, understanding the column, understanding car price, car name column. Okay, so how I can find unique pd dot unique df car name, so these are my car names, right? These are my car names. Now you can see that in car names, the first word is your car brand. Okay, the Alfa Romeo, Audi, BMW, Chevrolet, Dodge, then Honda Civic is Honda. Okay, then Honda Accord, then what? Yeah, Isuzu, Jaguar. These are car brand names. Okay, so I need to first extract these brand names, because if I start performing analysis on car name like this, I'll be having how many different observation I will have in a graph. 147, which is of no use to me. Okay, I need to clean this column first of all. Okay, so I'll start doing the cleaning process. Okay, so car name dot apply, or I will say dot split in space. Series object has no split column. Okay, let's say the split is not working over here. Car name dot apply. I'll form a lambda function, lambda x. Okay, x dot split. On what basis I have to replace some spaces? I have to take the first term. So you can see that I'm getting the car name here. So I'll just find unique of this. So, and then I can say a length. Okay. So there are 28 only. So out, like previously there were 147 unique values. Now there is only 28 unique values. Let's deep dive into what we are getting as uniques. Okay. We are getting something. Okay. Alfa Romeo, Audi, BMW, Dodge, Hyundai, Isuzu, Jaguar. Now you can see that Mazda and Mazda are same, but they are spelling mistake. Okay.
Sir, can you explain that lambda function, that lambda line,
Okay.
dot apply lambda?
Okay. Dot apply lambda. So what I did is, what I wanted is, I wanted the brand. Okay. This I want, like car manufacturer, brand, whatever we need to call it. Okay.
Yeah.
Now what you can see there, this is a car name. Like this is, there is a pattern. Okay. There's a car name. Okay. The first term is a brand name. Then there is a car
Hmm.
ka name, right? So
Right.
if I take this as my string and I do a split on this, split basis on space. So what I'll get
Ah,
is, I'll get Volkswagen Super Beetle. Okay. Now I
right.
only want Volkswagen. So I'll get a
Right.
0. So
Hmm.
I'm getting Volkswagen. So I'm
Got
applying this to the entire data frame. Like lambda applies to the each and every row at the same time.
huh.
Yeah. And this is with the
Yeah.
same thing. Okay. So that's how we are trying to extract this brand name out of this column, df.car name. Okay. So this was our column, right? df.head. If I do a df.head, this was a car name, and I'm trying to extract only the car brand name, like this Alfa Romeo or this. Okay, so I'll assign it to my car name column. So I'll change my car name as this. This is this. Okay, we'll do this. Now if I do again df head, I have this car name over here. Now we saw that we were having some sort of a spelling mistakes, and we need to clear that. pd.unique df car name. So we need to, first of all, lowercase everything, like everything should be in lowercase. Okay. So that is the first step I need to do. And then Mazda to Mazda, Toyota to Toyota, and Volkswagen to Volkswagen, VW to Volkswagen. Right? We need to do these changes. Okay. So let's try how we can do these changes. What we can do is, we say correct name, and we have to get combination. You can create a dictionary also, or you can give it in this way also. So what method you want to see? Like, should I create a dictionary, or should I give it in a list format? Or what else you can do is, you can do a simply like this: car name dot replace Mazda to Mazda in place equal to true df car name. I'll just copy this. Okay. Then what I need to change is Nissan to Nissan. Nissan to Nissan. Okay. Then what else I want to change is Porsche to Porsche. Porsche, which spelling is correct? I think this spelling is correct. So this will go here. Porsche to Porsche. Okay. Okay. Then Toyota to Toyota. What you need to do is this. This is the correct spelling. This is over here. And the last is Volkswagen to this is Volkswagen. Volkswagen. So we are assuming the second spelling is correct, okay? And I think VW is also Volkswagen. So we will do that also. So if you have smaller number of replacement, you can do dot replace function, okay, which will directly replace things. If you have large number, you have to create a dictionary or something like that. And then this, what it is saying, replace ka spelling, okay, replace. Okay, now all this replacement is done. Okay, so now I check the unique and I have this many unique. I don't see any spelling mistake, so I can check the length. Now it's 22. From 28 we are now to 22, right? So you understood what we are doing? Are you getting? Yes, no, bouncer, what it is? Yes, Priyanka says yes.
Yes, sir.
Okay, right. ठीक है. So now we have done this, right? Now next step, we need to do a analysis. So now what we'll be doing is we will be analyzing how car brand name affects the price. Okay, so first we will see distribution, car price distribution. Okay, okay, let's say we need to, we'll see plt dot figure fixed size, we'll say a 10 by 10 graph. Okay, plt dot box plot df car name df, and there is price, right? plt dot show. There is some problem, operand str and int. What is the problem? This is the graph that's been shown. Now I need to have a df dot car name, and why put it this? No, then we have to take a help plt dot box plot whisker position width bootstrap. Okay, let's try doing this with Seaborn if that works in a faster way. Some problems of matplotlib are solved by Seaborn, so we need to check. Okay, it's working. Let it script some. Okay, you got this. Now you need to have a bigger graph. Okay, I need to have a bigger graph, 30 by 10. If you take it, need to, let's increase it a bit, 15, and let's reduce it to 20. Now it's visible. I can reduce it further to say 10. Okay, now you can see this graph, right? What does it is saying is how for each brand my price varies. Okay, so we can see that companies like Alfa Romeo have a very small portfolio, right? Their price ranges in a very small range. Companies like BMW have a very high prices, BMW, Buick, and then Porsche, Jaguar, they are very high priced cars, right? So yes, brand name has an effect on car price. Some premium brands like Jaguar, BMW, and what is this, Buick, I don't know which brand it is, and Porsche, they play in a very niche market, like they play in a very high range car price market, and the Chevrolet is a very general type of a price, general type of a car. It's very, you know. So if what I can see, that if I'm working for Chevrolet, and I say if I prepare a car over here, then probably it will not sell, because my portfolio or my image is like I'm selling car in a very cheap range. Okay, so if I prepare a car from here, it will not work. Understood? That's what, that sort of insights you can uh, take out from this type of analysis, like where you have two variable, is called as a bivariate analysis. Okay, and when you have a single variable, you do it as a multivariate analysis. Like if I want to see only the price ka movement, and I created only for a price, like instead of this I would have something like this. I don't have I want to see only visualize price, like how is my price distributed. So this is how my price is distributed. There are few cars in this outlier range, like 30,000 and above. Majority of the cars sits in 5,000 to somewhere around 20,000, 27,000 ka range. Okay, and the average of my car price is somewhere around 11,000. Okay, so yeah, that's what sort of analysis we do for a car price with brand name. Let's see if any other analysis we can do. We try to create a scatter plot of price and say engine power. There's column called engine power, right? Where is that? There is power called horsepower, something like that. Okay, there's a power horsepower. So we'll try to plot a SNS and see if we can get anything. Scatter plot DF will have horsepower, will have price. First we'll plot this. So if you can see, as horsepower increases, my price also increases, right? And then we can have a hue which would be df dot car name. Let's say this. Okay, now it shows me with help of car name how the price is changing. Okay, so like this green belongs to what, Mazda or Buick, it will be Buick, like this. They are in a 45,000 price range and they have a horsepower like this. So you can find a relationship, like with horsepower and price you have this sort of a relationship, right? As horsepower increases, the price increases, and this is the distribution with respect to brands. Similarly, you can do an analysis like this. Let's say what is there, what else is there, like RPM, like I'll take city MPG, price city MPG, like city miles per gallon average, and how does these two relationship affect price. Key error, what is the key error? Price of P should be small. Okay, now you are seeing a specific thing over, like as my horsepower decreases, my city mileage increases. Okay, as my horsepower decreases, my city mileage increases, and my price is also less. As my horsepower increases, my mileage decreases, and my price also increases. Okay, so what you can say that I can create a car with a high horsepower, low mileage, and I can sell it with a very large, very huge price, right? That's what it is. Got the point?
Yes, sir.
Anybody have any questions? Are you understanding visualization in EDA? How does EDA works? Come on, guys, you can close off your, like you can open up your mic and say to me. Okay, clear. Then what else analysis we can do over here? We use these variables to do this. We do peak RPM, compression ratio, stroke ratio. Let's say so with car body we can do a similar kind of an analysis. Okay, with car body we can do a similar kind of an analysis. Okay, with car body, we can do a similar kind of an analysis. Car body. What is this car body? Okay, so like convertible cars have very high price range. Hardtop has is a very normal price range. Like it goes to 45,000. Now we can find out that this 45,000 will be having a very high horsepower, low mileage, and it will belong to like in this range, like Buick. Like this sorts of analysis you can do. Okay, getting the point, guys. Now we'll try to do a subplotting. Okay, we'll try to do a subplot. So let's say subplot matplotlib. Okay, we'll do this. This is very important. This will help you to create plots side by sides. Okay, in fashion. So let's say subplots. Okay, now I'm here, I'm here, I'm here, I'm here. Let's see some examples. Okay. We'll create this n rows, n columns, and index. Okay, so how many rows, how many columns, and what index I want. Okay, so let's say this is the index, 2 rows, 2 columns with no frame and all those things. We'll plot something in a subplot manner. Okay, let's say creating a subplot. Show you some good examples for that. We'll use this. Okay, so let's I use this. Okay, I'll use this. So what it is, I have 2 rows and 2 columns. Okay, I have a figure, I have 2 rows and 2 columns like this, right? You can see that there are 2 rows, 2 columns. Okay, now I can do a plotting in it. How I can do plot? Like this. I'll say like I'll take this scatter. Okay, I'll say access 1 1, like the first slide. I'll try to plot the first graph. So what I'm trying to do over here is this was what box plot, and scatter plot. Let's see if I can plot scatter plot very easily over here. Hue नहीं होता इसके अंदर, scatter के अंदर. It's matplotlib में, but yeah, we'll try to plot it. Okay, so this is 1 1, like this wala plot. I've plotted this wala plot. If I make it 0 0, this will be my first plot, right? This is my first plot. Now I need to have some second plot. Okay, second, this horsepower with price. Okay, I'll say 0 row and first column, right? Then I can go with first row and second column. Then I can go with CTMPG and price. Okay, so are you getting how I'm plotting subplots? Okay, yes, yes, sir, yes, sir, yes, sir, yes, sir. Okay, so we completed subplot, we completed this. Last thing that I want to show is a correlational plot. Okay, so df.head. Okay, so I'll try to keep only the numerical columns in. Okay, so df.dtypes. I'll filter, I'll take these columns, okay, in my data set. So float wale columns and I'll take all those columns, float and int wale. Okay, let's say I'll first, okay, drop this car ID. I don't need this car ID column, it's a simple ID. Access equal to 1, in place equal to true. So I drop this. I have df.head. I have this. Okay, so now I need to plot correlational graphs. So this is my correlational plot, right? With all those numerical column, how my graph. So this is correlation of coefficient, right? Pearson correlation of coefficient. What does this means? Symbolic to symbolic has a one correlation, right? So a variable with itself will always have a correlation of 1. Now symbolic with say price has a minus 0.79 ka correlation, right? Now you can see that price has a pretty high correlation with these values like 68, 57, 83. What is this variable like 83? This is curve weight. Price is a very high degree of positive correlation. We saw price is a very good degree of curve with average. This is what horsepower, right? You can see this is a very high degree of correlation. This is a negative degree of correlation. Why negative degree? We saw over here. As price increases, the CT MPG value decreases, right? So this graph shows us that. This is a visual proof that's there. That relationship is there. Now you can plot this into a heat map. So if I do something like this, heat map, okay. So this is a heat map. This is very important visualization to understand correlation in a very decent way, right? So the darker, the lighter part are with a very high degree of correlation, like this part. Somewhere around this, like 0.75. These are pretty light one, right? These are light one. These are having high degree of correlation. These are having somewhat of 0 degree. Then this is a very high degree of negative correlation, the black one. Okay, you can change this like sns.heatmap. There is color. You if you want to change the C map, so you need to change the C map of here. Let's see. This is the heat map. Okay. If I can, yes, this color. There's a color combination like this. This is a color combination. You can put it over here. You can do this also, right? You can change the color and all those stuffs. This gives you a visual appealing of the graph. Okay, understood this? Did you guys got it?
Yes.
Okay, so we completed this till here. Now our hypothesis testing part is remaining. Okay, so what we'll do in next 1 hour, okay, what we'll do in next 1 hour, I'll upload this car price ka data set over there, okay, in our drive. And for the next 1 hour, like after I will take a quick break of 15 minutes, 15-20 minutes. Like it's 11:05 in my clock. We can again get back at 11:25 or 11:30, and you will work for next 1 hour on this data set and try to create similar visualizations. Is it fine? Is it okay? Like you will be able to practice it, and you will be able to perform some these operations also. Is it acceptable plan, or do you want me to change my plan?
Okay, sir.
Okay for everyone. You can ping it on the chat box. Acceptable. Some says acceptable. Cool. So this will
Okay, sir, just upload this file also.
this file also. Do you want me to upload this? Then you will
Yes. So we can just refer to the codes.
Okay. I'll just upload this and this to the drive. You can practice it, and you can ask me any questions on live. Like you can share your screen and you can ask me questions. I'll help you over there. So this is CarPy's assignment and visualization.pd. Okay, I need to go to drive. So where is my drive? This is the drive, right? So I'll just pull these two. Okay, I have uploaded this visualization and CarPlus.csv file over there. Okay, get back from your break at 11:30 and start working on this. Okay. What you have? Yeah, Akansha to everyone value error df.core. What is the error at the bottom? So for this, I got this error, YNGBU. Akansha, can you share your screen with me and we can see what you have done? Just share your screen with me. How to share your screen? There is an option called share something, or you can write the you just remove the CMap and try if it's working. Remove the CMap and try if that's working. And which dataset are you working on? You're working on cars dataset or you have some other dataset? Okay, same dataset. Okay. So share your screen, please. We need to see where you are getting the error. I'll stop my screen sharing. You can share it. I'll stop my screen sharing. You can share your screen. Did you got the option to share screen? This is somewhere over here, like at the bottom. If you go near to your mic option, you have a screen share option.
Sir, I think you have to allow it to
You're
share
not
the screen.
okay. You're not. Akansha, I'll make you a presenter. You just share the screen. I'm making you the presenter. Just share the screen. Now, can you share your screen? Now you can see that option. Yeah, it's visible for us now. Yes. Okay. YGIBNU. Value error. Go to the down of the error. At the last, at the end, till then. Okay, these are the valid. These are the valid. YIGBNU. Okay, what's there in that? What's its name? Let me check it. It's it's YL. It's not Y1. It's YL. I think it's YL or Y. It's YL. It's not YI. Do YL. Yeah. Now it's working. Okay. Yes. Cool. Now you can stop the sharing. You can take a break of some time, and we'll again regather at 11:30 to do this case study. start the recording. So now we'll understand what is hypothesis testing. Okay, so hypothesis testing, let's say we perform an experiment. Okay, the experiment is like say coronavirus. Now coronavirus is affected by temperature or humidity. Now we need to understand, is this parameter actually affecting, or is this parameter not actually affecting, or the results that we are getting, are they by chance, or they are actually have some impact on that. So we cannot be 100% sure anytime that X parameter is affecting your results. Okay, so we need to do some sort of hypothesis test. So what does this it says? It says that hypothesis testing is a systematic way to test your claims or ideas about a group or population. Understood? So in hypothesis testing, you have something called as a null hypothesis and an alternative hypothesis. Okay. So what is a alternative hypothesis? First we will understand that. Alternative hypothesis is your claim, okay, or your idea. And null hypothesis is what the ground truth is. Okay. Say I say alternative hypothesis that the mean observation of two groups are not equal. So what will be the null hypothesis at 0? Their groups are equal. Okay, let's say. So there are two things. The null hypothesis. I don't know why this pen thing is not working. Just keep a moment. This highlighting erased all drawing pen. You guys are able to see my screen, right?
Yes.
And the drawing function is not working. I don't know why. Okay, whatever it may be. Okay. So how we do it? Okay, now there are steps to hypothesis testing. Okay, what are the steps? The first step is to state the hypothesis. Okay, the second step is to set the criteria for decision. The third step is to compute a test statistic, and the fourth step is to make a decision. Okay, that are the four steps into any hypothesis testing. Okay, and there is concept called as null hypothesis. Null hypothesis is which we presume to be true. Okay, so null hypothesis state that null is a statement about population parameters such as population mean that is assumed to be true. Okay, this is the starting point. Let's say I say that the population mean is 50. Okay, that's my null hypothesis. My alternate hypothesis will be that it's not equal to 50. That will be my alternate hypothesis H1. Okay, so what it says is we think it's wrong. So keep in mind, the only reason we are testing the null hypothesis is because we think it's wrong. So what we are thinking is that the population mean is not 50. That's what we are thinking. That's why we are testing an alternative hypothesis. Now let's take an example. Let's say we take an example. Let's say for a particular area. Okay, the mean people infected by coronavirus is say 20. Okay, that's the mean. That's the hypothesis that I'm testing. So what will be the alternate hypothesis? It's not equal to 20. It's greater than 20. It's less than 20. Okay. So if I say, if my alternate hypothesis is, let's say the mean number of people affected by coronavirus greater than 20. So my alternative hypothesis will be, my null hypothesis will be it is less than or equal to 20, right? Got how you create alternate and null hypothesis? Ruchita says yes. Other people? Ashwini? Okay. I will once again repeat it. Okay. For all people to get it clear. So alternative hypothesis is basically what you want to test. Okay. Say I want to test like the mean age in any particular region is greater than 20. This is my alternative. This is what I want to test. Okay, so what it would be? It will be mu. So if my drawing pencil things works now, I'll be able to show you. It's not working. I don't know why. I'll just open up Paint. Okay, so right now if it works. Okay, so now what is my alternate hypothesis? Alternate hypothesis, I show it by H0. Okay, pardon this because I'm not using a pen tab. So it says that the mean is less than equal to 20. Means what is this? What I mean to say is the mean age is less than or equal to 20. What hypothesis I'm testing? The mean age is greater than 20. This is my alternative hypothesis that I want to test. This is what we called as an alternative hypothesis, and this is what we called as a null hypothesis. Okay, so this is there. Now once we have that, there are a lot of things we need to find a level we need to set a decision criteria. Now what is decision criteria? We cannot be 100% sure about our observation. Okay, there is something called as margin of error or error, or what you call level of significance. So typically what we say is uh, we set a criteria of say 5% or 1%. So that's a level of significance. Okay, which means that we are able to our observation or our testing is prone to 1% error. Okay, or a 5% error, which on alternative way what we means is we are if we are have a level of significance as 95, how much error level we can expect. Okay, so it's the standard is 1, 5 and 10%. Okay, so what is 1% error? That means I am 99% confident of my alternate hypothesis testing. If we set 5%, we say that we are 95% sure that our hypothesis testing or observation is correct. That's what it means. So let's see understand definition. uh, okay, level of significance refers to the criteria of judgment upon which a decision is made regarding the value stated in null hypothesis, criteria the probability of obtaining a statistic measure in a sample if the value stated in null hypothesis were true. Okay, this means our confidence of this is normally called confidence level, how confident we are with our testing. Okay, so yeah, now let's see this. Let's say let's say what it is. The children were watching less than 3 hours of TV. Okay, here the children are watching more than 3 hours of TV. So what was the null hypothesis here? The children were watching averagely the children were watching 3 hours of TV. That was the null hypothesis. Okay, what was the alternate hypothesis? The children were watching not equal, the average time the children were watching TV was not equal to 3, means they were watching less or they were either watching more. Okay, so this is like, okay, now we need to compute a test statistic and we need to find how far we are from our mean. Okay, so basically we have to find how much standard deviation we are from far from the mean. So if we are somewhere lying in this range, we will reject or accept a null hypothesis depending on that. Okay, so now we compute a test statistics. Okay, now the test statistic is basically we perform test like Z test or T test. We'll see when we'll perform a Z test, we'll see when we'll perform a T test. Okay, so the test statistic is a mathematical formula that allows us to determine the likelihood of obtaining the outcome if the null hypothesis were true. Okay, so that's what we need to do, and then we'll make the decisions. So okay, so we can make two decisions. We can reject the null hypothesis, or we are failed to accept, or we accept the alternate hypothesis. That's a two-way. Okay, to do this. Okay, so now reject the null hypothesis means that the associated is low probability of occurrence when the hypothesis is true. Retain the null hypothesis means that that's where we fail to reject. So Retain means we fail to reject the null hypothesis. This means the sample associated with a high probability of occurrence when the null hypothesis is true. Okay. So now what is p-value? Now the p-value is the probability of obtaining a sample outcome given that the value in the null hypothesis is true. So we have given an observation and we found out the p-value is close to our level. Okay. Then we say we accept or reject. Say p-value is less than 5%, we reject the null hypothesis. Okay. If my p-value comes less than 5%, this means what? If my values lies in this two range, okay, then we reject our null hypothesis. If the p-value is where it went. Okay. Now if the p-value is this greater than 0.5 or 5%, we retain our null hypothesis, which means that we fail to reject the null hypothesis. Okay, we fail to reject the null hypothesis. That's the thing. Like we are not rejecting a null hypothesis. We are saying that the mean hours that people are watching TV is 3. That's what we are observing. Understood till now? Any questions?
So the p-value, how do we get the p-value means?
Yes, how we get the p-value? We do the test statistics, okay, and from that test statistics we get the p-values. There are standard tables. Like if you search z-score table PDF, the standard normal distribution table. Okay. Proceed to North Arizona. Okay. These people have created this. So you can find this table. Like there is a probability that the z-score. There's a z-score on the left and the table like 5%. So you have this range, and you have the score. What the score you will get, a positive, negative score, and you have to find this value. Like this is a probability value. This is basically a p-value. Okay. So this is more than 1.6 is more than 95% p-value. Understood how you'll get the p-values from this table, that z-score table. Okay, if you're doing a z-test statistics. So now this is your structure, right? You have a population, and you state the null hypothesis and alternative hypothesis. Okay, you select a level of significance. Okay, you conduct a test, like you conduct a study with a sample selected from a population. You measure a data, compute a test statistics, you check it with level of significance, you make a decision whether to accept or reject the null hypothesis. Okay, this is the standard SOP to follow. Okay. Okay, now these are the statistics that you can calculate from it. That is mean, variance, and standard distribution. Okay, standard deviation, sorry. So for sample it's shown like this, for population it is like this, for sample it is shown in this way. Okay, and based on that, if the population mean or standard deviation is available or a sample is available, you will decide whether you will do a p-test, whether you do a z-test or you will do a t-test. Okay. Okay, so now what is a t-test? Score of what is a population distribution? Score of all person in the population are available. Okay, sample distribution, sample of select, like we do a sampling from the data set and then we take a population mean. Like we cannot take, say I want to say the average population of India is average age of the population of India is say 35 years. I cannot do it. I cannot go to every person and check like what's their age. We do a sample distribution, like we to take samples from each city and calculate a mean. Okay, and then we do this kind of analysis like hypothesis testing. Okay, now watch it over here. What is the shape of this distribution? Population distribution can be of any shape, sample distribution could be of any shape, but the distribution of the sample means is always normally distributed. Why this so? Why this so? Because we have something called as central limit theorem, right? We studied that in class. What is central limit theorem? The distribution of the means is always a normal distribution, right? We have studied that. Yes or no? Guys, yes or no? Yes, Rahul says it. So that's
Yes.
what central limits
Yes.
theorem says. Okay. Okay. Now we will understand types of errors. Okay. Now, if our p-value comes in this range, like 1 minus alpha, alpha is what? Our acceptance range, like 0.5, 0.05. If our p-value comes in this, we accept the null hypothesis. If it's true, and it's true, that's called correct. Okay. If it's false, like it's 1 minus beta, the power of the test, it's called power of the test. Then there's some type 1 error, like the null hypothesis is true, but we reject the null hypothesis. That's type 1 error. Okay, the actual observation was true, but we rejected it with the help of our hypothesis testing. That's the alpha, that is the level of significance that we put in the test. That's what we call as the type 1 error. Okay, what is type 2 error? Okay, we accept the null hypothesis, but actually it was false, so it's called as type 2 error. Okay, I say the level coronavirus affecting the people is say 50, is say 30%. That's what the hypothesis I was testing. Okay, I accepted this hypothesis by some test, but in actual scenario, the rate at which it was affecting is more than 40%. So I committed a type 2 error. Okay, because I retained a null hypothesis when it was false. Understood? Type 1, type 2. This is a question in interviews, right? Okay, this question comes in interview. Type 1, type 2 error. Can you give one more example? Okay, you want one more example. Okay, so let's take an example. Let's take an example of say data science job environment. Okay, let's take an example of data science. My hypothesis about the population is, let's say averagely or meanly 70% of the people doing data science course get a job. That's what my hypothesis is, null hypothesis is. Okay, now I do a sample analysis, okay, sample t-test, and found out that my null hypothesis is true. Okay, so I retain my null hypothesis, but in actual scenario, there were less than 70% people who are getting job in the environment, in data science environment. So then what I did is I committed a type 2 error, that I retained the null hypothesis where actually it was wrong. Understood? Type 2 error?
So, but according to our analysis, our hypothesis was correct, right?
Yeah, so these are errors. Okay, these are so you cannot say that you cannot say I created a drug for COVID vaccine. I created a COVID vaccine, and I tested it in lab and tested in some 10% population, or some sample population. It worked over there, and it will work for the entire population. Is that the scenario?
Okay.
You are still you are hearing news that people, even after getting COVID vaccine, are getting affected by corona, right?
Yes, you are saying that after the hypothesis testing, after the use of it, we can know the errors and all, and that's the second error.
Yeah, right. What's actually happening?
Okay.
We are doing this thing in lab. Okay, we are not going on the ground, and we
Yes.
are not testing on 100% population. So that's what it is.
Mhm.
Because we have a type 1 error already involved in our test. So that's 95% or 9. We have some confidence index. Okay, like we are 95%
Okay, sir.
confident about it. So understood? Type 1, type 2 error.
Yes, sir.
Okay. Now let's go down.
So,
Yes.
so, so are we going to use this in our means testing, an analysis?
It depends where you work. Okay. It depends. It actually depends on where you work. If you work in some finance company, there is hardly any chance you will use this. If you go and work in a financial or a credit firm, like the loan banking thing, you in pharma companies you will 100% use this. If you work for a banking sector credit decisioning thing, there is a 70% chance that you will be used, 70 or 80% you will be using once in a lifetime. Okay.
Okay, means in pharmaceutical company we are using hypothesis testing mainly, maximum times.
Just give me a moment. Just give me a moment. Yeah. So where were we? Yeah, sorry. Yeah. Yeah. In finance company, you say 50% times you are using it. Okay. And but in pharma companies, say 80% times you are using it. In credit companies, there is a 70% times you are using it. Okay. So that's how it flows. Okay. Guys, can you hear me?
Yes, sir.
Yes, so it was mute for like 20 seconds.
Yeah, there was some network issues. Okay. Okay. Now, there is a one-side test. There is a one-side test. There's a two-side test. Okay. So when we do one-side test and when we do two-side test. Okay. So when we do one-side test, when we say that when our alternate hypothesis is like this, our mean is greater than, say, in this scenario, you can see this scenario here. We will do a one-side test. Okay. Because we are testing on one side only, right? If I had something like this, like my h0 was mu mu not equal to 20, right? So what does that mean? My h1 will be less than, so my mu would be either greater than 20 or it will be less than 20, right? So this will be my mu. It will be either greater than 20, it will be less than 20, right? So in this case, I will perform a two-side test. Okay. So non-directional, directional, two-tail test or one-tail test. That's what it's called. Okay. So let's go here. My mu is 5558 and my mu h1 is, the mean test scores are not equal to 558 in the population. So set up the hypothesis with significance of 0.5. Then we will calculate the critical value. We'll split it into half, like 2.5, 0.250 and 0.250 on both the sides. Okay. And we will calculate the test statistics. Okay. and we'll see whether our test statistics lies in which range. Like these are the rejection range. Okay, over here we'll reject the null hypothesis in this range if my t statistics comes here or over here. Okay, now you understand rejection region. Now we will do our z scoring. Okay, which is average, which is m minus mu upon sigma. M is the population mean. Okay, sigma is a population mean, and we'll see the sample mean that we have. Okay, so we'll calculate a z score. My z score is coming 1.94. Okay, now the value obtained is 1 point, which fails to fall in this region. Okay, which fails somewhere over, it's not in this region. Okay, so what we'll do is we will retain the null hypothesis. We will not reject the null hypothesis, because for 95% or 5% level, my critical value is 1.96. Let's see in table if we can find out. If my z score, if I say 5% level, and let's say 95% confidence index. So this is, you see this 95% confidence index. So this is 1.65, right? This is 1.65. Okay, so any value less than 1.65, okay, we will accept it. So it's coming 1.94, right? Z score. So we will accept it. Understood? Okay. Now, when we have, so here we are calculating this. Okay. Now, when we perform t-test, we'll see that. Let's put some more down. Okay. Let's go down. Let's go down. Let's go down. Cohen population size, sample size. This, if you want to understand in detail hypothesis testing. Let's go more down. Okay. There is type 1, type 2 error. You have all those definitions. Now it's this very end. So I need to go up. I'll just find t-test. So you perform basically t-test when you don't have okay. Let me go up. There is a beautiful table which shows us when to use what. Okay. So when you have population mean available, okay, when you have population mean available, you perform z test. Okay, when you have a sample mean available, and there was an observation over here. I need to check where it is. Z test alpha level. There has to be somewhere over here. Test statistic. Okay. So let's search when to use z test and t test. Okay, so they will get okay. Okay, so when we use t-stat test when we want to compare sample mean with the population mean. Okay, and we use z-test when we don't have information on the population variance. So this is a basic condition. You can use this graph. Okay. So if your sample size is greater than 30, you perform z-test or t-test. Okay, if your sample size is less than 30, you see if you have the population variance available or not. If your population is not there, you perform a t-test. If your population is known, you perform z-test. Okay. So in that manner, you perform hypothesis testing. Okay. It's a pretty manual process. You can automate it with Python. Everybody got this? I know it's difficult to digest in one shot. Did you people get this? Yes. If any problem, you should tell it now. We'll try to find out.
So, what kind of questions should we expect from the interviewers
Okay.
about this topic?
Okay. The questions like what is type 1, type 2 error? Okay. This is the first question. What is one side test? What is one tail test? What is two tail test? This is second question. Okay. What is the level of significance? Okay, that is the third test, third way. And when to use Z score, when to use Z test, when to use T test. That's the fourth type of a question you can you can expect. But if you are giving a data science interview, okay, there
Yes,
is
sir.
20% chance or less than 20% chance if they will ask you for this hypothesis testing.
Okay.
There is a very rare chance if they will ask you for hypothesis testing. They will ask you about algorithms, data cleaning, pandas, numpy. Okay. If you are
Then means they will mostly ask us about the technical part, about the
no
Python, Panda,
pandas, numpy
MATLAB.
technical part as well as on the algorithms part. Okay. Linear regression.
Okay, sir.
Ask on that.
Regression functions and all.
Yeah. There is a very rare chances. There are chances. I'm doing this hypothesis testing with 95% confidence that they will ask mainly on this. Okay. But there is
Sir.
5% error, like there are type 1, type 2 errors. It can happen. If you are unlucky, then he will ask you this.
Okay,
You
sir.
can say that. Okay, guys. Any questions for today's session? Any questions? At least no question. Put it in the box. No question. Ruchita says no questions. Yes, guys. So you have your case study for Tuesday. Solve it. Try to come up with insights. Prepare a presentation, a 3 or 4 slider presentation, and present it to the class. Okay. I'll randomly choose people on Tuesday to present it. Is it fine? Everybody understood?
Yes, sir.
Okay.
Okay, sir.
Okay.
So
So how
we have to
was?
make a presentation after that.
Yes.
Presentation means PowerPoint presentation.
Yes, you have to make a PowerPoint presentation and you have to present both your PowerPoint presentation and your Jupyter notebook. Okay.
Okay, sir.
So this will also improve your soft skills.
Yes, sir.
Okay. So yes, any feedback for today's session? Like yesterday, I received a feedback that I should speak slow. Any feedback for today's session? Okay. Okay, guys, then enjoy your weekend and do practice this problem. Okay. Thank you, everyone.